assume we were to find the equation for the projectile motion. Okay, let's say I want to find this. I want to find the governing equation of an object that is launched at an angle theta with a velocity of v0. We already know that this object would take a path that goes something like this. And this path here is called the path of trajectory. Now let's assume a point here called x, y. Okay? If I were to ask you to give me or to derive the mathematical equation that governs this path of trajectory, which means what I'm trying to say is, if I were to ask you to give me a mathematical equation in the form of y as a function of x without t in it. So I just want a function that relates y, the variable y, which is the vertical distance here, and the horizontal distance x, without having the variable t in it. Then we would start from the basic rectilinear kinematic motion, s equals to ut plus half at squared. Since we're going to analyze this in the y direction, then we would say sy equals to uyt minus half gt squared. Since we know that acceleration in the y direction actually equals to negative g. Okay, substituting sy with y equals to v0 sine theta t minus half gt squared. Okay, how did I get v0 sine theta? Because if you remember correctly, the initial velocity has a component in this direction which is v0 cos theta, and it has a vertical component in this direction which is v0 sine theta. Okay, so that's how I got v0 sine theta there. Now from the formula again, s equals to ut plus half at squared, if we were to analyze this in the x direction, then we would say sx equals to uxt plus half a would be ax t squared. But I've already discussed this, and we are in a common understanding that ax actually equals to 0 since there will be no acceleration in the horizontal direction. So this term here equals to 0. Sx from this diagram is the displacement in the x-axis, which is x. Ux is actually v0 cos theta. So v0 cos theta times t, which means to say that t equals to x over v0 cos theta. Okay, let's call this equation 1, let's call this equation 2, and let's see what we get when we replace equation 2 into equation 1. Since we don't want t in our equations, then upon replacing equation 2 into equation 1, we have an equation that looks something like this. Y equals to v0 sine theta. T here would be x over v0 cos theta. So x over v0 cos theta minus half g. T squared would be x squared over v0 squared cos squared theta, which is actually can be simplified to x tangent theta minus half gx squared over v0 squared secant squared theta. So this is the equation that relates y and x, and there is no t in this equation, and this is the equation that governs the path of trajectory. Thank you.